second item on the agenda, which is whether or not we should enable auto MTLS in 1.4 release.
Hey, folks.
Okay.
You're using actual service accounts. Yeah, but like.
Jean-Fei, do you want to talk about?
Can you show me your
Or Josh?
Like, do you use a service account?
I don't actually remember adding this, and I have a lot of background noise. Jean-Fei, do you want to talk?
Yeah, it uses the.
Jean-Fei, you're muted.
We could also discuss the transport security alternatives, and then come back to auto MPLS. Louis is with us now.
Yeah, I'm just trying to find somewhere quieter. It was pretty noisy where it was. Give me 2 minutes. All right, hopefully this is better.
Yeah, that's good. Do you want to present the doc or should I?
If you don't mind.
Do you want to give us an overview, Louis?
Yeah, sure. So the basic discussion is, there's Istio is trying to provide, a transport security mechanism to allow people to basically modernize their security best practices without necessarily being too disruptive to how, the network is defined today. And we've tried to do this by essentially trying to wedge MTLS into the network on all the existing application ports. And we've had to do quite a bit of work in Envoy and in the control plane to do this, because if you're trying to share with the application port, you don't necessarily want to force on MTLS because that might break external clients. So you have to support this permissive mode thing, and the way we do that is by sniffing traffic. And there's just a decent amount of complexity in how we're enabling this transport security feature. And we're running into some limits with that system and with that complexity that are becoming more and more challenging to deal with. And so this document was an attempt to explore alternatives to see if we could do something that provided the same feature set, but in a way that was a bit more maybe standardized with industry best practice and more supportable within Envoy. And there's a few examples I put in the doc about some of these challenges that we faced. Protocol sniffing, particularly TLS sniffing, is complicated. It doesn't necessarily work that well with server sends first protocols. We have to do timeouts. It really does add quite a bit of complexity to the networking stack and how we configure Envoy. And then there's a variety of other things with the solution that we have today that are basically in the same category. So the kind of fundamental alternative proposal is to kind of create a dedicated transport, networking abstraction, kind of like an L3, L4 abstraction, below the level of kind of cluster, et cetera, in Envoy, that provides a transport security feature. And we can still use MTLS for that, but it's a transport in the Envoy sense. And so it doesn't collide with other behaviors of Envoy, and in particular, it doesn't share application ports, so we don't have to do sniffing or things like that. And so really what we would do is we would have something that could route at L4 based on the existing configuration, what we already send to Envoy, but provide MTLS, and it would just be entirely opaque to the end user. Like, it doesn't bleed into the APIs in ways that kind of affect application behavior. Right, so it's almost like there's a VPN. that would probably simplify Envoy's behavior quite a bit. And we've been running into situations where we've had to start asking Envoy to do things with protocols that are non-standard, and we can't require that Envoy bends to our will effectively to enable these kinds of features. Like, I don't think that's practical when they have other users and our use of those features is non-standard. So there's that kind of class of tension. And then there's, okay, well, if we want to shift to something where there's a stronger separation between the kind of lower level, transport level abstraction and the application level abstraction, then what would we like it to look like? What does it need to do? And what benefits might we get if we made that kind of transition? So this document describes, effectively what we need that transport to be able to do, how it needs to behave, what properties it should have, and what kind of abstractions it should present. Because the other thing we should assume is when implement, one of these physical network abstractions, there's a good chance that we'll go and implement a better one later, or a more performant one, or some vendor might go and want to go and plug in their proprietary one or something along those lines. And so we should design the system in such a way that that layering enables evolution and replacement without breaking the higher levels of the system, right? So there's a contract, a formal contract between this lower layer and the higher layers of the system. And a good example of this might be, let's say you were using Flannel, and Flannel has an IPsec feature, and that IPsec feature carried workload identity, right, end to end, and you could read that out of the network endpoint. Well, if you consider that reliable enough and performant enough, then you wouldn't need to use an Istio implementation or an Envoy-based implementation of transport security, because you'd be happy with what the underlying network was doing. And because you could read identity out of the network, you could still implement policy, right? Because the big thing we do, aside from kind of the properties of encryption around confidentiality, integrity, non-repudiation, etc., is we reliably propagate identities so that we can enforce policy on application level traffic, right? What we do in authorization policy v2. And I think that's the kind of definition of the contract that we want. All right, we want an abstraction, and I think it would probably be good for Envoy to have a kind of interface abstraction which codified some of these things in such a way that that replacement could occur, because it will help us evolve the product over time if and when we want to implement a better transport. And then I listed out a bunch of kind of transport implementation options that are based on pretty well understood technologies in the industry today. So basically having a dedicated port for transport and then just using a tunneling protocol. And we could use MTLS plus the proxy protocol because we need to carry through destination port, etc. We need to carry through the L3 properties. And so there's a few variations. Most of the variations listed out in the document are all using a dedicated kind of tunnel port and then just using different kind of encapsulation protocols over it. So I talked about the HA proxy protocol, using HTTP Connect, using SOCKS. And then there's a couple of other variants which, in addition to having a dedicated port, also multiplex all the streams over a single connection, right? So then we're talking about HTTP2 and QUIC, although QUIC is a little different. And then also I talked about IPsec, kind of that Flannel example that I gave. And these solutions come with varying costs, right, to implement, to support, performance, etc. And so I think, assuming we can come to some agreement, there's kind of two parallel tracks for discussion. One is, do we agree that we might want to make a change in how we do transport security to look at creating a stronger separation between the layers? And if so, how do we want to define that contract? And how would the higher levels of Istio change in response to that? Because there would probably be some API impacts and some documentation impacts, etc. And then a second track, which is, okay, which transport should we use? And that doesn't have to be just one, right? That probably means designing so that there can be one now and then others in the future. And how would people transition across those boundaries, et cetera, upgrades? So those are the kind of two major themes that we should discuss. It's probably worthwhile discussing the first one, right? Are the advantages or disadvantages of moving to a stricter transport layer separation worthwhile? And then a second discussion about, well, okay, and which one? Make sense to people?
Yes, thank you for the overview. Any opinions?
How fast can we go there?
Yeah, I agree. Should we? So I think probably everyone thinks this is a wonderful approach. Do we need to discuss more which are the specific alternatives?
So I know Sriram still has some questions about this part, but I don't think he's on the call.
Yeah, he's not.
So I'll try and follow up with, like, he had some more kind of fundamental questions. And, so one reasonable question he asked, and because all of this plays into kind of security posture, today, the options Istio gives you are basically the admin, and the options are given to both admins, like the mesh admin, and to, let's say a namespace or service owner. At the admin level, you kind of get the option is like, do you care at all about security, right? And if you don't care, you're not going to put any constraint on any of the traffic on the network. And then the next so that's kind of like the plain text setting for authentication policy today. Then the next setting we give you is permissive, which is like, well, you're trying to get to a secure posture, but you're not there yet. So you can't put this hard constraint on traffic flowing over the network. So you're going to allow plain text and secured traffic, but you want to enforce policy when you can. And then the third one is, I want to be strict, right? No traffic can move across the network without being, confidential or having integrity checks, et cetera. So, encrypted. And, in parallel to that, you probably have policy checking enabled on it.
But,
and we give you a hard cliff because we say the only way you're only strict or you're only considered secure if you're only using our mechanism of encryption.
Can I add a quick comment here? In reality, it's not that black and white and simple. I mean, yes, we say it's strict, but in reality, strict means that anyone in the mesh can connect to your workload. It doesn't really mean any security posture, because you can only get security if you actually have an RBAC rule and you specify only workload ABC can connect to me.
Yeah, right now I'm only talking about whether
I know encryption or not encryption, but that's kind of a tiny part, and strict of gives a suggestion. It's misleading to users, and permissive is neither there nor there. It's kind of
the terminology doesn't actually describe what's happening very well.
Exactly, and that's probably a problem that we need to address, because permissive is not really, it's as bad as insecure, but gives the impression and has a complexity of MTLS.
And one point that Sriram brought up is, if you look at most deployments today, there is some traffic flowing between workloads, right? And and I'm talking about deployments that aren't using Istio yet, where their traffic is already secured, right? They may be doing, application level TLS directly, right? They might even be doing MTLS. And to go into those deployments and say, look, as far as we're concerned, that traffic is insecure. And the only way you can make it secure is to enable MTLS, actually causes some friction for adoption. So there's probably a variant of, just the posture with respect to transport security, which is, if the application is already using a secure protocol, then that's fine. And it's only for the protocols where we don't know what they're doing that we would maybe go put them onto some other transport mechanism to make them secure. And a good example here might be gRPC, right? You might use the gRPC client talking to a server, And they may do MTLS, right? Because gRPC is adding support for this, or there's plenty of other solutions out there that do. And then let's say you'd go and deploy Istio, but you only deploy it on the server side. Now the client might have to change, even though what they were doing end-to-end was actually secure. And that's probably not a good thing. That's not a good choice to kind of foist on the end user. So we might actually want to have this kind of mode where we say, look, your security posture is strict, but we don't require that everything uses secure transport that's implemented by Istio or is bespoke to Istio, right? If you're using MTLS at the application level, we consider that to be strict as well.
But we will be losing identity, right? And that's one of the features that Istio provides.
Right, but the application might be doing an identity check.
It's providing, not forcing.
Right. So it's an interesting choice, right? It's for all the things you don't know or aren't sure, you probably want to put them just by default onto some generic secure transport. But for things that are already secure, and that you have some confidence in as an admin that the applications are doing the right thing, do you want to also do that? Because one issue we have with, if we're going to do a transport level abstraction is there will be situations where there are non-Envoy clients talking to envoys, right? And then we'll have to, right? They may not support that transport mechanism. And so you're going to rely then on the ability to configure some alternate means of terminating a secure protocol. What was already a secure protocol.
I would add here that many times the user knows better what their applications are doing than us trying to guess it and put everything in buckets based on. So maybe just giving the users a tool to control what ports are allowed, what ports are not allowed, and set their own policy if they choose to, because if they care about, they will probably write a policy and they'll write network policy or other things.
Yeah, so we actually have most of the APIs to represent these concepts today.
Yeah. And Kubernetes has network policy as well on top of that.
Right. And it really just depends on the recommendations we give to users about how to use them to achieve the security posture that they want. So one of the options here, and I think I talk a little bit about it in the doc, is, if we enable a generic secure transport using some tunneling protocol, we could have made the option is well, if you're in strict mode, we turn off all the application ports to ingress traffic from the network. We could refine that to say, unless we think that that application port is already secure. And then we would allow it to just continue as is. We would still allow traffic to it also over the secure transport, but it wouldn't force all the clients to migrate. But you could still consider that a strong security posture. And then how do we represent that in the API? Does that make sense to people?
Yes, I'm just wondering how different this is from what we currently have.
So obviously the port sharing. So the difference would be, we wouldn't try and layer MTLS over the existing application port. We would stop doing that. Really what the application owner would say is, look, this application port is already secure, right? For whatever definition of is secure they're comfortable with, right? And that could be, is it using MTLS? Is it using TLS or something else, right? And separate that from the physical, the transport tunnel that other envoys or other clients would use. And then that application port could accept traffic coming in via either mechanism, right? But we wouldn't, for traffic that was coming from an envoy going to something that was already considered secure, we probably wouldn't put it over the secure transport.
Correct. Yeah, what I'm saying is I think this is kind of orthogonal to whether it's on the same port or dedicated port, right? can still provide those features.
Yeah, the issue with if we're going to use MTLS as the means of implementing or layering in a secure transport, port sharing is problematic, right? Because we have to sniff, right? Because we don't know what they're using to secure it. That leads to timeout server send first issues, and it also ends up with situations where if the underlying protocol was TLS, right, and we're not currently doing TLS over TLS, or except, well, unless they declare it to be TCP, you could end up in situations where you have certificate authority collisions, right?
I don't believe that's true. I think we detect whether it's service mesh TLS or workload TLS.
That's the ALPN label, right?
Yeah.
But if the underlying, right, but we can still have clients have collision problems, right?
I don't believe so.
I was trying to think of a scenario where this would happen. How do we do the detection today based on the ALPN labeling, right?
Correct.
And we know that that's problematic.
Correct. But there is a way to move away from it if we
Adopt
inventory with
right, the certificate authority matching.
Correct.
But we could still have
that has its own problems.
Right, because then you could, right, imagine you had application level TLS and Istio level TLS sharing a common CA.
But you don't control the CA. I mean, you can use external CAs, all kind of combinations.
Right, so that's what I mean by don't control, right? Yeah. They're not different issuing authorities.
And multi-cluster and all the other stuff that are.
Is that a real use case?
Well, with managed CA at Google, right, the root CA is the Google root CA. So you'd have to match not to the root, you'd have to match to an intermediate root. And you'd have to say that you can only use the intermediate root for the mesh, and you can't use any certificates issued from that intermediate root for the application level.
I think that's fine.
Do we even have intermediates here?
Right, but now we're partitioning intermediate roots across infrastructural boundaries instead of across domain boundaries.
I mean, it's already too complicated.
Right, and we haven't implemented the intermediate roots yet. Right.
Yeah.
Correct. I think
so just separating across different ports for a variety of reasons seems practical and would avoid that issue.
Well, one comment I have there is the primary goal for the port sharing that we have right now was that when we were originally designing this, it was, I think, #1 requirement to use the same ports to avoid, new firewall rules and stuff like that. Whereas we are now explicitly rejecting this requirement.
But was it a strong requirement? Where does the requirement come from, and is it really something that was a good requirement or bad requirement? We have experience with people who are using Istio. Do they really use network policies, which is firewall rules, and is this a proper way they want to use it? Because that actually prevents them from using network policy as intended, because with network policy, you can say don't allow access to port 80. With Istio, you never know what port 80 is going to be. So it's not clear if we are actually improving things or making things worse for firewalls.
Yeah. So
because with permissive, it can be plain text, it can be not be. Who knows? And it's a.
What about it? Then it's still the same service on the same port, right? So they can block access to this. Whereas if we have dedicated service mesh wide port, it makes it harder to blacklist access to services at the firewall level. Right?
For this, we will need to use Istio policies because again, that's or we need to enforce the policies. I mean, we need Istio itself to enforce the same policy on this port, but that doesn't change the situation that Istio needs to enforce some security policies one way or another. Before, I mean, currently we just the network policies are completely useless because we kind of make a and they have to use Istio policies. In the new world, they will still need to use Istio policies for Istio port, but can choose what to do with the other.
Yeah, so I guess the answer is I'd like to hear more opinions about the value of aligning with the underlying firewall rule, right? consider the use cases, right? If you don't care about getting to the kind of Istio world of this strong transport security model end to end, right? Where you can just leave all the application ports as is, right? And your underlying network firewall rule will keep working. But the reason to go and turn on the Istio security policy is mostly so you can enable the RBAC policy, right?
Yes.
Right. Yeah,
Assuming we
you
don't
may
start
have.
using tokens other identities, because there are other identities that can be used without MTLS.
Right. I mean, there's lots of ways of propagating identity, which we could talk about. We could even reverse lookup IPs if you considered your IP registry, you know, one, available enough, and two, reliable. But so there's the reason why we use a transport encoding is because it improves the availability of the system to do this, and it provides confidentiality. And there are reasons why you want confidentiality and integrity. But if you're going to make that transition, you are making the transition probably to using RBAC. Now, we could look at better ways of, like, maybe MTLS was the wrong choice because it collides too easily with TLS, right? And we could just do something like proxy protocol and do MTLS over proxy protocol, right? And then the detection, right, would be more deterministic. Right, so the other solution is...
But that wouldn't solve the server speak first.
No, it wouldn't.
It would, because server speak first are perfectly fine if you start the tunnel. The tunneling protocol you're talking about with dedicated port.
Yeah, no, with non-dedicated ports.
Oh, with non-dedicated, but that's again still complex and unnatural and uncommon. So,
right. I mean, we could look into options for it.
if we really want to make it work, but again, the question is, is it worth messing up with expectations and normal order of things just to be smart, or should they just...
And maybe the answer to this, the longer term answer to this, Peter, is if you want to work with underlying network firewall rules, then you should work with an underlying network that propagates identity.
Yeah.
Right? So one of the things I'd like to do is to have that interface abstraction. So we could go work with networking providers who are willing to make assertions to their customers about the security of their system and integrate that up into policy and telemetry. And at least if we create an abstraction, then people can go do that, and then we can go and talk to the networking providers and say, look, guys, we have this option, this fairly simplistic transport security option. Or go talk to a user, right, and say, look, we have this transport security option. It uses a tunneling protocol. It has all these good features, but if you don't like how it interacts with your network firewall rules, then here's your options, right? Go run a lower level network overlay that's providing you VPN-like features, so you get confidentiality and integrity and identity propagation. And we'll make sure that there's an abstraction over that, so it still works with telemetry and policy, and you're good to go. I think that's a reasonable kind of compromise to make for this situation.
Yeah, I agree. Do we know of any deployments that would break?
We don't know in advance, but we can certainly ask around. So I think one thing, considering the tracks, right, there's kind of, I can certainly go ask the customers here at Google, does this matter to you at all? And that should be a track that we follow up on. So, like,
yeah, because that's one of the biggest changes with this proposal, right? And then whether we can switch to that.
2 comments. There may be an intermediary situation where if you have permissive, you replace permissive with this mode, because permissive is the one causing most problems. Or first move permissive to this mode, and maybe leave strict, because with strict you know that everything is MTLS. You know that, I mean, if you declare a port as being MTLS, we can just treat it as MTLS.
Yeah, that's not an unreasonable option. Right, that just means you're reverting back to the application ports deterministically.
Yeah, it means a port will be plain text or can be TLS. It can never be in gray area. It's either one or the other. And you choose what it is. It can be MTLS because we make it MTLS or the application is making MTLS. But you don't have to use proxy protocol if you are clearly one way or another.
But then we are back to the issue, what happens during transition period, right?
That's a short, I mean, then you are in permissive mode and use a proxy protocol. That means
so
maximum performance in after the transition, and transition is.
Yeah, the issue is that, as designed, the permissive mode was also supposed to be only used in transition, right?
Exactly, and we are using it by default.
It became the default.
Permanent transition.
Yeah.
So everyone is paying the price for transition if they are not transitioning.
Yeah.
In the default installation of Istio.
So wouldn't we end up in the same situation with, with dedicated MTLS and strict back on application port?
That's not a transition.
Wouldn't we put everybody in transition mode by default?
No, that's not a transition mode. That's a default mode, which is you have your ports are as you want, as you implement them, and you have this extra ways that is used for Istio and for other applications that use the proxy protocol. It's not even Istio specific. If we go with a standard protocol like connect or proxy, any load balancer could go to this port and.
So I guess I'm still confused as to why we can't just use a separate MTLS port for every application port. Wouldn't that solve most of these problems at the expense of a lot of ports?
That's an option.
I think the cost there, if the only reason why we're worried about migrating to a tunneling port is because we're worried about what it does to the underlying firewall rules. And we're debating whether we actually care or not.
How many ports are we talking about?
Could be many. For
1,000?
For
Well,
RTB applications.
Remember, there are applications that dynamically allocate ports.
Yeah.
Okay.
And
but the question is, would we use single dedicated Istio MTLS port for everything and tunnel it, using metadata, or would we have one for each service?
Right. So
that's one question, but
then how do you rewrite the underlying firewall rules and say, look, I used to be on port 80, so now I need to be on 9080, right? And I have to understand that 9080 is the MTLS version of 80, or whatever transport protocol it is, right?
I want to add that it's not a bigger picture is here that is that telemetry also needs metadata, and they are implementing some sort of hack to pass TCP metadata in some sort of headers at the beginning of the protocol. So with telemetry is also super important, and we also can use pass identity and other things for TCP protocols in the proxy headers.
There is actually a drafted IETF right now from Ben Schwartz at Google that implements this as part of TLS. So you get, I think you get integrity as well, or you get integrity and basically encrypted TLS metadata that's bidirectional.
But that's still,
When's that happening, Piotr?
And it's TLS specific
No.
again. We it's not entirely sure we want to be tied to TLS forever and not.
Well, that's the protocol abstraction interface inside Envoy. That's different.
Yeah.
The actual protocol choice for the transport, right? We just have basic requirements on it. It should be relatively. The goal is to make it relatively fungible, right? Right. We should be able to transition from TLS plus HTTP connect to quick, and the application wouldn't even notice that anything happened other than CPU changed, right? That would be a goal. That's a very specific goal.
And quick is actually a very important point here, because if we can have everyone to transition to quick by using either connect or something over quick, then we are in a pretty good shape.
Or any one of H2, right? The only issue with H2 is, do we have unreliable streams over H2? That's getting a bit more into the which one kind of rabbit hole.
Mm-hmm.
Yeah.
But John, coming back to your point, that's the reason why right now I was a bit wary about having basically one additional port for every application port, because you have to know what they are if you cared about the underlying firewall rules. It seems easier to tell people just whitelist the tunnel port and go use Istio or RBAC to get the property that you want. Does that make sense?
Yeah, that makes sense. I mean, it depends on what they're trying to do with their firewall rules. If they're doing fancy things, it might be better to, if they had a way to access, a way to block the transport, the same way they could do it on an application port by blocking, the corresponding MTLS port.
So just a point of order. So far, the only people who've talked in this meeting are Googlers. Any non-Google people want to weigh in? I saw Lizanne just dial in.
Well, I'm still catching up on this proposal. I don't have anything to weigh in right now.
Okay. I certainly know Sriram has opinions, and I chatted a bit with Zach from TouchRate about this yesterday. But I do want to make sure we get some diversity of opinion.
Yeah.
In the community. All right. So leaving aside coming to the other track for a second. We could talk about the nuts and bolts of which protocol would actually make sense in terms of implementation cost, practicality, utility, etc. So Costin brought up yesterday the point that the proxy protocol doesn't communicate metadata from the server back to the client.
So this is something that TLS metadata does.
Yes. So Piotr, do you want to add a pointer, and I'll go and update and point to, I guess, the RFC for the MTLS?
Yeah, I already linked it.
Okay.
My preference is actually for Connect protocol, which does this also already, and it's well supported already in shitload of applications because it's been a standard since the beginning of time.
Anyone have specific concerns? So there's a specific concern with proxy protocol. Anyone have specific concerns with MTLS plus Connect?
You mean HTTP1 Connect or HTTP?
Either one or two or three.
That's actually a benefit. Yeah.
Connect works on all three.
Well, let's start with HTTP1 Connect, and then we can talk about HTTP2 Connect.
Unless it's harder in HTTP in Envoy to differentiate between them because there are some layers as well.
No, like HTTP2 Connect is very different than HTTP1 Connect.
Yeah, how does HTTP2 Connect work today?
So each stream,
It's just a stream.
I'm talking about the extended connect method, which is used for bootstrapping WebSockets.
But WebSocket and Connect in HTTP2 are just HTTP streams. Nothing special about them, as far as I know.
Yeah, so I think the question, the thing I was chatting with Josh yesterday about 1 versus 2, right? Anytime we use a multiplexing protocol, right, is there going to be an issue with doing KTLS or splice or any of those other kind of kernel offloady things?
Right, it adds to the cost significantly. So the way I was looking at this is H2 is an optimization. Kernel offloads are basically a competing optimization, and it's hard to say which one is better. The thing I liked about the Connect approach was it sounded like there could be a layer on top that decides, basically there's an abstraction layer where you decide whether you do Connect over HTTP 1.1 or Connect over HTTP 2, and then we could have basically Connect over HTTP 1.1 with offloads competing against Connect over HTTP 2 and see which one does better. But it sounds like there's a lot of code involved in doing that.
I hope it's not a lot of code really, because in reality, it's the main thing is to make it use Connect. And I think HTTP 1.1 is probably the right one because most existing applications support 1.1 really. Connect 1.1 is the one that is broadly adopted and standardized for a long time. So yeah, let's go with 1.1 first.
Peter, Lizanne, John?
Yeah, that sounds great to me.
Yeah.
In terms of offloading, KTLS work obviously with both HTTP1 and HTTP2, because that's just the transport security. Splicing is gonna be harder with H2, but you have frames, so it's gonna be harder to implement, but it should be also possible.
But
right. I mean, there's also, I guess the other part of that kind of performance assessment would be, HTTP2 with DPDK or FDIO or some non-kernel based IO layer. At which point it might be more practical to talk about Quick than HTTP2, right?
Yes.
So that might be the choice.
1.1
is-
versus Quick.
Are we considering that choice right now?
I don't think we have to. I don't think we have to decide now.
Okay.
I think we have to pick. Like it's pretty clear we could go do HTTP 1.1 connect,
Over
right? And that would be
TCP.
fair. That's probably the lowest cost implementation.
Okay.
Well, with the exception that it's not supported in Envoy right now.
Yeah, we'd have to go do work in Envoy.
Yeah.
But the work for proxy and connect is the same thing. Basically, you need to stuff some bytes at the beginning and parse some bytes at the beginning as a response. It's not really.
Well,
It's
Piotr,
something
do you-
more complex.
Piotr, do you think there's a meaningful implementation difference between, or is the cost of doing Connect and Envoy super high? HTTP 1.1 Connect, or is it not that hard?
Piotr, there are two implementation of H11 Connect. I mean, one is where you actually use the HTTP stack, and the other one where you just parse a bunch of bytes terminated /n as a header, like we do SNI sniffing, for example. I mean, you just
We
cut
don't-
it.
They'd have to use the stack, I think.
Yeah, we
otherwise
cannot like
vulnerability.
add another HTTP parser, custom parser, because we had issues with just the.
Yeah, they have security issues.
Yeah.
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 But also, HTTP2 Connect is implemented in Envoy, so we could use that.
It is implemented.
Yes,
But 1.1 is not.
correct.
Huh.
Because of two different features, right? The HTTP2 Extended Connect is used for tunneling versus HTTP1 Connect is is used to establish TCP connection using HTTP.
Then,
Browsers.
yeah. So then why don't we use connect over HTTP2, and then if we want to do the kernel offload work, part of the kernel offload work would be adding connect over HTTP 1.1.
That's fine.
Piotr, to confirm, is both client and server implemented? So both cluster and listener implemented?
Yeah, I believe so. Because then it's just H2 stream.
Keep in mind that proxy protocol is already implemented. I mean, we have HTTP proxy with absolute URLs and everything else, but it's missing connect. So it cannot be used with a browser because of this tiny missing detail.
Okay, but Cousin, it sounds like
Yeah. No,
we
that's
already
good.
have we basically already have an implementation, more or
That's
less.
perfect.
That
And then
could be
the-
wired up.
The only question I had is, I think in the connect section of the document, there is some concern I kind of zipped past about this being an abuse of the semantics of connect.
Of HTTP Connect?
Yeah.
No, that's what it's meant for. It's meant for the
All right.
exact.
Okay.
Well,
Apparently I
it's
dreamed
the
this.
typical use case of HTTP Connect, right, is to be able to go through an edge firewall, and then it's very common to do TLS once you've connected. This is actually the other way around, where you're doing TLS and then you're connecting within TLS. Both are fine. Both are perfectly valid.
Right.
It's just one is
Yeah,
more
sure.
common than the other.
Connect is meant for proxies. Envoy is a proxy. Perfect
Yeah,
fit.
it's
QED.
the sandwich is the other way around in this case. So
All right.
it's-
So
it's-
should we write this down as a decision that we're basically going with connect over H2?
So I think we should just in
this
the notes, the agenda notes, to say we think the H2 extended connect over H2 probably already works out of the box.
Yeah.
There's no specific objection to HTTP Connect, HTTP 1.1 Connect.
Yeah.
It just isn't there.
And we might introduce it as part of the kernel offload work. If it
Yeah.
helps. Yeah.
And we might introduce it
yeah.
anyway in Envoy because it's a widely used feature.
I would add one more horse. I forgot about it. Since we're talking about things that already exist, over WebSocket, because WebSocket also sends headers in both ends, and then upgrades to a regular TCP
Well,
connection.
that's what the H2, the extended connect is now.
No, but plain HTTP 1.1 WebSocket.
Like the internet is very hard pushing away to move
Yeah,
all
I know.
WebSocket to H2. So I don't think we would bother. Yeah.
If we want to try the splicing, I mean, that would be a way to test slice without.
Yeah, I can just rename the HTTP2 one to WebSocket over HTTP2,
Yeah,
and it would mean the same thing.
No, but that's still framed and doesn't work in kernel. If you want to do kernel-based splicing and other optimizations.
Yes, no, that's why we'd have the HTTP one.
Yeah, HTTP 1.1, but WebSocket over 1.1 is actually equivalent with anyway.
Well,
never mind.
WebSocket still has framing, so you'd still have to deal with framing.
But it'd actually be easier, I think, than H2.
It's very similar.
Is it? Okay.
It just doesn't have the header dictionary.
What about the HPAC stuff or some?
Yeah, that's the
compression?
issue.
Yeah.
The HPAC
Yeah,
Yeah, that's the
stateful
issue,
stuff.
really. Yeah.
You can also do stateless HPAC if you want. You can enforce it,
Yeah, you can disable compression and just use half one.
which Envoy actually does. Right, that feature exists in
When-
Envoy.
Yes, it does.
So like that, there's no. We could actually get to the point where we do a variant of H2 with splice, and right, we just have to spec it out.
Interesting.
Lizanne, does that sound
Yeah.
reasonable to you?
Yeah.
So I think the other thing we want to do is to, in the transport abstraction in Envoy, put in the right level of interface abstraction so we can do the things that we talked about, right? Where we can read peer identity out of the transport and metadata. Right,
Yeah.
and have that be able to propagate into attributes and things like that.
Yeah, so I think that's just you need a filter to extract that information from TLS, right?
But are the right abstractions there? Because now we're moving down below cluster level TLS right into a transport level interface.
I think
Well,
it's already abstracted in Envoy.
right.
So like, TLS is just, variant of transport second. I don't think we have everything abstracted away there, but we could definitely add peer identity and stuff like that.
Right. That's not completely abstracted, but kind of already abstracted.
Okay. Well, maybe Piotr or Lizanne, do you guys want to think about what such an abstraction might look like
Sure.
as an AI, and we could add it to the doc.
Sure.
Okay. I think that's all I had.
Cool, thank you. Any comments? Any other items to discuss?
Yes, auto MTLS.
Oh yeah. Do we want to make it default or not?
Yeah,
Like,
and
that's the question.
I think there's a very immediate concern that we've already done both community testing episodes already, so it's arriving pretty late.
Oh, it wasn't enabled in either of them?
Right.
Oof.
In context of this discussion,
What do we want to discuss the current status of the risk of this, or even longer term for beyond 1.4?
I think given the 6 minutes we have left, let's just talk about 1.4 right now.
Okay. Yeah, I think indeed we mostly for now only have covered the CD test that we have for the REPL, and we don't have we discovered several issues, but they are resolved or kind of expected because of the overhead of the TLS intrinsic overhead, and we didn't get a chance to do the larger scale to measure the concrete number of the TLS overhead to give them better number recommendation for customers during the upgrade. I think that's important. I agree. And so from the API's perspective, since this is a backward compatible change, we shouldn't expect any breakage with the current usage. We should only see some bump up for the latency or the CPU due to the TLS overhead. That's the summary.
that's a breakage, really. I mean, the fact that we are now waiting for TLS certificates, which means that pods that started in few seconds now start in tens of seconds, that's kind of not...
Yeah. So Jean-Pierre, I guess I was looking through the the issues in the pull request this morning, trying to get the context. And I got to say, I think you did a wonderful job. I think that you really, it was a big effort and you did a lot to get it to where it is. I think that enabling this by default after community testing would invalidate the testing that's done. We just can't do that. I think our options are either repeat the testing and delay the release, or let this go in 1.5. What do you guys think?
So, yeah, thanks. Like, I am fine with that, but I just want to clarify. You mean let this go to 1.5, which means that let it on by default for 1.5, or still keep it as an optional for 1.5?
I would say.
Say, assuming that we have enough testing for performance, we have done all those exercise.
Yeah. So I think it's a timely question. So yeah. So I think we're already in the point where it's opt-in, off by default for 1.4. So we can have people try it and we can get feedback from that. For 1.5, whether we default it on, there's additional testing work you can do, and that could say we want it on. But we now have this other competing effort with Connect over H2 in the title article.
I don't think that's Connect. It's competing. Louis,
It's not competing.
Okay, good. So
well, they're kind of competing because
would we want both?
I think we want both. That's my understanding. Louis, you can.
So auto MTLS, the feature is, I want to be in this state where I'm migrating as quickly as possible to a security posture, right? And there are specific steps that I take to do that. The proposal for the different transport is still part of an auto better security posture migration, right?
Yeah.
It's just like, if it was default, if auto MTLS was default on, it would be equivalent to the base state of the secure transport, I think. So they're not strictly competing. They're just, they provide the same feature in two slightly different ways.
Which is not competing, it's cooperating. They are cooperating and providing a solution.
Yeah. So,
but one question, what is wrong with saying that if you are migrating from plain text to MTLS, you enable it? If you are not migrating, you are not in this permanent migration state. So basically, you enable this feature if you are trying to migrate. Otherwise, you leave it as it is. In 1.4 and 1.5, basically, it's kind of.
I think that's a product question, where what kind of the most majority use case we are trying to trade off, right? Whether we want to give better out-of-box user experience for MTLS compared with our competitors like Linkerd, or versus we require customer to do one more thing. It's a trade-off of that, right?
right. So I think that the only decision at this point is the feature on by default or not? The feature is obviously shipping, and customers can opt in. And the only argument about not having it be on by default was it hasn't gone through community testing. And there's no community testing scheduled between now and the release date, right, Josh? Did we lose Josh?
But I think the answer is yes.
I have two monitors that I couldn't get the mouse over to unmute. It was driving me nuts. Is John Howard? My understanding, I don't know if we have any other one for Louis Managers. I don't think we have.
Yeah, I'm on.
Do we have any other community testing scheduled between now and the release?
We do not.
All right. So that's the only decision point here, I think, John.
Sure.
Given the impact of the feature, I don't think it's a big thing to ask users to do to flip the flag in this case, right? Because the impact is pretty extensive when you do it.
So why don't we document it as an experimental feature in the release notes and describe how to enable it?
Okay, so we can, if we not on by default, we should have a dedicated page to explain the impact of this feature and what people get out of it, right?
Well, no, it would be off by default, but in the release notes.
Yeah, that's what I'm saying. Yes, what I'm saying. So that people are aware of there is a feature for this.
Yeah, it should have documentation for sure. Not just with the release notes.
So right now you probably have some way to doc about how to turn on MTLS. I assume you could just put this there. Like if you don't want to deal with all the config, just set the auto MTLS and then.
Yeah. Lida, you want to say something? I saw you.
No.
Okay, sure.
Fine.
All right. So the decision point is about community testing, and given that we don't have that, we can have it off by default. And then once we have it, have some more user feedback, there is no more blockers for making it on by default in 1.5. That's what I get.
Yeah, probably not. Like yeah. So we just want to take a look at the user experience around enablement, but
get more coverage exposure of the potential feedback from the. All right. Sounds good.
Yeah, and I keep harping on this, but and this is not this is something that this is a problem we have in a lot of different features, but actually having tests that try to exploit or bypass and actually hit security bugs. I'd love to see more of those. It's a general statement.
Sure, we can see more on that.
Yeah. Okay.
All right.
And with real applications.
Sure, I think part of the OKR is to have more enterprise applications, like paid for applications for that. I think that can give us better coverage. Should we document this in the doc so that we can sure you remember what we discussed?
It should go in the notes. It should go in the meeting notes.
Okay,
Yes, agreed.
Thanks. All right, see you guys.
All right. Thanks, everyone.